Hello everyone, I am Rajput Shubham Ajaykumar, a PhD scholar in the Department of Chemical Engineering at IIT Madras. Today I am going to talk about my research work based on design of lead-free 2D halide double perovskite ferroelectrics. So the term ferroelectric materials are the materials which have inherent electric fields which can be separated or enhanced with the help of external DC power supply or by shining light on the material. So what will happen when you apply voltage or shine light? The electrons will align to the one side and holes will align to the other sides. So this electron hole separation within the materials reduces the recombination rates within the materials, which can enhance the efficiencies of the solar cells and it does. Now, before going to the application of the ferroelectric materials, we have to identify whether the material is ferroelectric or not. So they have been characterized using the hysteresis phenomena, which is known as polarization electric field loop. And these materials have been shown to have added advantage over the conventional halide perovskite materials because they have shown to reduce the recombination rate of electron and hole charge carriers, ultimately increasing the efficiency of the solar cell fuel cells, dielectric capacitors, reducing the recombination rates in lithium and sodium ion batteries, splitting water efficiently into hydrogen and oxygen, and converting CO2 to value-added fuels such as methanol and formic acid. So our research problem is based on 2D materials, but most of the materials that has been reported in the literature are three-dimensional, means it goes in three different directions, and that too are based on the lead. So since the lead is toxic, we have to replace the lead with the other materials, elements available in the literature in evidence. So we are working on replacing the lead with +3 charge elements and +1 charge elements, combination of these two in order to make another material which is known as halide double perovskite. So double here means two different octahedras present. Now since our goal is to identify the directional properties of the single crystals in multiple directions, we can make this 3D into 2D by replacing this small cation with a large aromatic ring or the aliphatic ring. So this is how we go from a completely symmetric to asymmetric system. So our objective is based on identifying on developing new materials which has not been reported in literature till now, and identifying the direction dependent properties like in two different directions or three different directions, and ultimately identifying the conduction mechanism, the charge carriers within the material. So we are able to identify and develop one of the material which has been not been reported till now, which is CPEN, and this material has shown the hysteresis phenomena in two different directions. One in the one direction it shows a capacitive loop. So this material has been proven to show one of the highest spontaneous polarization, which has not been reported in any of the 2D halide double perovskite ferroelectric in the literature till now. And further, we have characterized this material with the help of the dielectric impedance spectroscopy, atomic force microscopy, and pre-conductive force microscopy in order to further characterize this material at the nanometer scale. And the similar material has been reported and published in the small journal recently, which is one of the highly reputed material science journal. And the similar kind of other material which we have also worked on has been reported in the CANCOM.